Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square minus 5d plus 6 into y equals to e power x sine square x. So firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so our order will be 2. And highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y minus 5dy plus 6y equals to e power x sine square x. We know that d is a differential operator. Then d square will be d square by dx square. Right? Now we can write our equation as d square y by dx square minus 5 into dy by dx plus 6y equals to e power x sine square x. Right? Here d square y by dx square is the highest derivative. So our order will be 2. And highest power of the highest derivative is a degree. Degree is 1. Now coming to the problem. Given differential equation. D square minus 5d plus 6 into y equals to e power x sine square x, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 5d plus 6 and q equals to e power x sine square x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is the complementary function, yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. So let's begin with yc. Now we are going to find yc using the roots of homogeneous equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, so we are having f of d equals to d square minus 5d plus c 6. Now we need to replace differential operator d by m, so that we'll get f of m equals to m square minus 5m plus 6. Now our auxiliary equation will be m square minus 5m plus 6 equals to 0. Right? Now split minus 5 as minus 2m. We'll split minus 5m as minus 2m minus 3m plus 6 equals to 0. Now take m common from the first two terms. We'll get m times m minus 2. And take minus 3 common from the next two terms. We'll get minus 3 times m minus 2 equals to 0. You notice we are having m minus 2 in both the terms. So let's take m minus 2 common now. We'll get m minus 2 into m minus 3 equals to 0. Now equate each factor to 0. From m minus 2 equals to 0, we'll get m equals to 2. From m minus 3 equals to 0, we'll get m equals to 3. Right? Then m equals to 2, 3 are the roots of our auxiliary equation. Right? Here 2 and 3 are real and distinct. So we got real and distinct roots. Therefore, m equals to 2, 3 are the roots of our auxiliary equation f of m equals to 0, which are real and distinct, or we can call them as real and different. Okay. We know that when two roots say m1, m2, are real and distinct, then yc will be one constant into e power 1 root into x plus another constant into e power another root into x. Now let's write a complementary function. Yc equals to constant, one constant into e power 1 root into x plus another constant into e power another root into x. Then yc will be c1 e power 2x plus c2 e power 3x. This is a complementary function. Now let's find particular integral. You can find particular integral using 1 by f of d into q. We have f of d and q, where f of d is d square minus 5d plus 6 and q is e power x into sine square x. Cos 2 theta equals to 1 minus 2 sine square theta, right? Then bring this minus 2 sine square theta to LHS, will get 2 sine square theta equals to, take this cos 2 theta to RHS, will get 1 minus cos 2 theta. Now take this 2 to RHS, will get sine square theta equals to 1 by 2 into 1 minus cos 2 theta. Then for theta equals to x, will get sine square x equals to 1 by 2 into 1 minus cos 2x. Right? Now we'll replace sine square x in q. Now it becomes 1 by f of d e power x into, replace sine square x by 1 by 2 into 1 minus cos 2x. Since 1 by 2 constant is constant, so we'll take it towards left. Then we'll get 1 by 2 into 1 by d square minus 5d plus 6 into e power x into 1 minus cos 2x. Now yb becomes 1 by 2 into 1 by f of d into e power x into 1 is e power x minus, or just write it as e power x into 1 e power x minus e power x cos 2x. This becomes 1 by 2 into 1 by d square minus 5d plus 6 into e power x minus 1 by d square minus 5d plus 6 into e power x cos 2x. Now we'll find each term separately, right? So here the first term is of 1 by f of d into e power ax form, and second term is of 1 by f of d into e power ax into v form. Okay, so let's begin with the first term. 1 by d square minus 5d plus 6 into e power x. Since this is of 1 by f of d into e power ax form, so compare e power x with e power ax, then we'll get a equals to 1, right? We have f of d equals to d square minus 5d plus 6. Now let's find f of a. For a equals to 1, we'll get f of 1 equals to replace d by 1, we'll get 1 square minus 5 into 1 plus 6 is equals to 1 minus 5 plus 6 equals to 1 plus 6, 7 minus 5 equals to 2, which is non-zero, right? We should always remember that the denominator must be non-zero. If we get denominator 0, we'll get something like this. Since 1 by 0 is undefined, so 1 by 0 into e power x will become undefined, right? But in our case, the denominator is non-zero. Since f of 1 is non-zero, so what we can do? We can just replace d by 1, then we'll get 1 by 1 square minus 5 into 1 plus 6 into e power x, which is equals to 1 by 1 minus 5 plus 6 into e power x, which is equals to 1 by 1 plus 6, 7 minus 5 into e power x, which is equals to 1 by 7 minus 5 is 2 into e power x. Or we can write 1 by 2 into e power x as e power x by 2. Therefore, 1 by f of d into e power x equals to e power x by 2. Now we need to find the second term. 1 by f of d into e power x cos 2x, right? Now compare this with 1 by f of d into e power x into b. For a equals to 1, we need to find d plus a, which is equals to d plus 1. Let's shift e power x towards left by replacing this d by d plus 1. Then we'll get d plus 1 whole square minus 5 into d plus 1 plus 6 into cos 2x, right? This becomes e power x into 1 by expand d plus 1 whole square using a plus b whole square formula. We'll get d square plus 1 plus 2d minus 5 into d minus 5d minus into plus minus 5 into 1 5 plus 6 into cos 2x. This becomes e power x into 1 by d square plus 2d minus 5d is minus 3d plus 1 plus 6 is plus 7 minus 5 into cos 2x. This is equals to e power x into 1 by d square minus 3d plus 2 into cos 2x. Now we need to find d square is equals to minus of a square, which is equals to, now just compare this with 1 by some function of d into cos ax form. Okay, forget about this a and d plus a now. Just compare this term with 1 by function of d into cos ax. For a equals to 2, we need to find d square, which is given by minus of a square, which is minus of 2 square, which is equals to minus 4. Now, we'll replace d square by minus 4 and see what happens in the denominator. The denominator must be non-zero. Okay, just take the denominator part and replace d square by minus 4. We'll get minus 4 plus 2 is minus 2 minus 3d, which is equals to minus of 2 plus 3d, non-zero, right? What happens if we get non-zero in the denominator? After replacing d square, we'll just get 1 by 0 into cos 2x. Since 1 by 0 is undefined, so the total term becomes undefined, right? So the denominator must be non-zero. Now, we can replace d square by minus 4 here. Replace d square by minus 2 square, which is equals to minus 4. Then this becomes e power x into 1 by, replace d square by minus 4 minus 3d plus 2 into cos 2x, which is equals to e power x into 1 by minus 4 plus 2 is minus 2 minus 3d into cos 2x. Now take minus common from the terms of denominator. We'll get minus of 2 plus 3d into cos 2x. Now bring this minus outside. Then we'll get minus e power x into 1 by 2 plus 3d into cos 2x. This becomes minus e power x into 1 by 2 plus 3d into, here we are having 2 plus 3d, right? Just change this plus as minus, then we'll get 2 minus 3d. Now we need to multiply and divide 2 minus 3d to this fraction, okay, into cos 2x is equals to minus e power x into 1 into 2 minus 3d is 2 minus 3d by 2 plus 3d into 2 minus 3d into cos 2x. This becomes minus e power x into 2 minus 3d by, in the denominator we have 2 plus 3d into 2 minus 3d, which is of a plus b into a minus b. We can write it as a square minus b square, that is 2 square minus 3d whole square into cos 2x, right, which is equals to minus e power x into 2 minus 3d by 2 square is 4 minus 3 square d square. 3 square is 9 into d square into cos 2x. Again, d square appears in the denominator. So what we have to do? We have to see what happens if we replace d square by minus 4 in the denominator. So take the denominator part and replace d square by 4. Minus 4, right? Is equals to 4. Minus into minus plus. 9 4s are 36. Is equals to 40. Non-zero term or non-zero number, right? So the term becomes non-zero by replacing d square with minus 4. So what we'll do here? We'll just replace d square by minus 4. Then this becomes e power minus e power x into 2 minus 3d by 4 minus 9 into minus 4 to cos 2x is equals to minus e power x into 2 minus 3d by 4 minus into minus plus 9 4s are 36 into cos 2x, which is equals to minus e power x into 2 minus 3d by 4 plus 36 is 40 into cos 2x. This becomes minus e power x into, now split this fraction as 1 by 40 into 2 minus 3d into cos 2x, which is equals to, now bring this 1 by 40 outside the brackets, we'll get minus e power x into 1 by 40 is minus e power x by 40 into 2 minus 3d cos 2x, which is equals to minus e power x by 40 into 2 cos 2x minus 3 cos 2x. 3d, right? We have d here. D is nothing but differential operator. So we need to find derivative of cos 2x. d by dx of cos 2x. Then this becomes e power minus x by 40 into 2 cos 2x minus 3 into derivative of cos 2x is minus 2 sin 2x, which is equals to minus e power x by 40 into 2 cos 2x minus into minus plus 3 2s are 6 cos 2x. So this is sin 2x, okay, not cos, sorry. Now take 2 common from these two terms, we'll get minus e power x by 40 into 2 times cos 2x plus 3 sin 2x, okay, 2 ones are 2 20s are, which is equals to minus e power x by 20 into cos 2x plus 3 sin 2x. Therefore, 1 by f of d into e power x cos 2x is minus e power x by 20 into cos 2x plus 3 sin 2x, right? The second one. Now coming to yp. Yp becomes 1 by 2 into result obtained from the first term is e power x by 2 minus result obtained from the second term is minus e power x by 20 into cos 2x plus 3 sin 2x. Which is equals to 1 by 2 into e power x by 2 minus into minus plus e power x by 20 into cos 2x plus 3 sin 2x. This becomes e power x by 1 by 2 into e power x by 2 is, I'll write another step, okay. 1 by 2 into e power x by 20 into cos 2x plus 3 sin 2x, which becomes e power x by 4 plus e power x by 40. 2 into 20 is 40 into cos 2x plus 3 sin 2x, which is our required yp. So we got yc and yp. Now we can write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to, we have yc, c1 e power 2x plus c2 e power 3x plus yp e power x by 4 plus e power x by 40 into cos 2x plus 3 sin 2x. This completes the problem. Or we can write it as y equals to c1 e power 2x plus c2 e power 3x plus e power x by 4 plus 1 by 40 into, take this e power x inside the brackets, we'll get e power x cos 2x plus 3 e power x sin 2x. Right? So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.